Okay, let me start this thing again. So thank you for reminding me just now. Okay, this is your IC. Kalau you tengok dekat IC ni, dia ada satu benda. Dia kat sini dia ada notch. I hope you can see this thing. There's notch. So you count IC ni punya kaki daripada notch. Dekat notch tu bawah tu ada titik. So daripada titik tu 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. So just like apa nama for this. So bila you masukkan tu, the way you want to put your IC, masukkan separuh and then you push. Bila push tu nanti dia akan tertolak ke sebelah situ, baru you boleh tolak ke bawah. Okay. That is how you do it. So kalau you nak pull, patutnya ada IC puller, but you know, with my experience, I'm just using my finger to pull this thing. So if you have to pull this thing, you have to use both finger and you have to pull this thing simultaneously, top and bottom. Supaya bila buat macam tu, kaki dia tak akan bengkok. Kalau tak, kaki belakang dia tu dia akan slightly twisted. So bila orang lain nak pakai, kaki dia akan patah. So you push this thing and then okay. So saya dah tunjukkan dalam video a good lab practice on how to do the experiment. Okay. The first experiment will be on finding logic gate, logic level. Okay. I will switch off this thing. I'll go to my computer. So saya will switch this. How to switch this thing. So I'll be off camera. Macam mana nak off camera ni? Oh, stop video. Okay. Alright. Mute. Okay. Ini apa? Oh, there will be some delays. Okay. All right. So our experiment today is on first experiment is on logic gate, finding logic level. Ini bukan ini bukan digital kan? Ini bukan digital lah. 2121 rasanya.
Yes, great.
Okay. All right. The first experiment is on finding logic gates. Sorry, logic level. All right. Bila kita tengok dalam your experiment kan, sebelum ni awak belajar logic 0, logic 1, dia ada either logic 0 atau logic 1. So what is the voltage level for logic 0 and logic 1? Logic 0 will be depending on the technology used. Kalau misal kata logic 0 for TTL will be from 0 to 0.7 volt. That will be logic 0. Logic 1 will be from 2.5 volt to about 5 volt. That will be your logic 1. Okay. Logic 0 from 0 to 0.7, 2.5 to 5 volt is logic 1. That is for TTL. For CMOS, logic 0 is from 0 to about 0.6, 0.5 macam tu. That will be your logic 0. Logic 1 will be from 3.3 volt to VCC. So you can put VCC from 3 something volt, 3.3 volt, depending on the technology of the CMOS being used, 3.3 volt, sampailah ke 12 volt. That will be your maximum voltage for CMOS. Untuk TTL, maximum voltage is only 5.5. More than 5.5, you will burn the IC. Okay. Semua itu ya. So I will open the chat. So if you have any problem, if you you can ask any question daripada chat.
Sorry to interrupt,
Yeah.
Doctor. The lab manual Doctor gave us is a physical lab, right? But in the table that Dr. Ashraf gave us, it was in online. It was online lab.
Okay. So I will do the lab today. So saya akan upload the lab, and then you just draw the conclusion from the lab that I will do. I will do your lab tomorrow sebab saya tak ada stand. I'm sorry for this. Since this is online, so I'll do all the experiment for you. Okay?
So our task is just to write the conclusion and discussion about the lab.
You tengoklah apa saya buat. You have to do the simulation. You do the simulation part.
All right, thank you, Doctor.
Okay. So most of the experiment, I will do it for you. So I will do the experiment tomorrow, and then I will upload dekat dalam apa nama ni, I'll put it dekat dalam YouTube. You take a look at it, and then you just like you do the experiment by your own. Okay. Am I answering your question? I hope I'm answering your question. Okay.
Yes, Doctor. May I ask, can we do with partner because there is a grouping?
Yeah, you can do with your lab partner.
So the discussion part and conclusion part is not
the
the
discussion
same?
part and conclusion part is your own. Even dalam lab, when you do the experiment, physical experiment, I mean, when you do the experiment physically, face to face, you have to draw your own conclusion in discussion by your own, not by grouping.
Okay, Doctor, thank you.
All right.
May I know the due date?
Sorry?
May I know the due date of the lab?
Due date will be on Friday lah.
Oh, okay, thank you.
All right. Okay, so okay. Ada apa-apa lagi nak tanya? So I hope the lab manual is clear enough for you to understand. So first experiment is on finding logic level. So kita dah tahu, macam saya cakap tadi, logic 0 is from 0 to 0.7 or 0 to 0.5. 0.7 TTL, 0.5 is CMOS. Logic 1 for TTL is from 2.5 volt to about 5 or 5.5 volt maximum voltage. For CMOS is from 3.3 and above sampai maximum 12 tu your IC dah start panas, lalunya maximum is 9 volt. Okay, now what happened between 0.7 to 2.5 volt? So this is the area yang kita panggil indeterminate state. So kadang-kadang when the logic gate is not being tied to ground, means that you are not connecting the ground, or the ground is loose, or the ground is not connected properly, then you will see that your output will be around 1.8 volt. So this okay, so I will differentiate between what is discussion and conclusion at the end of the class. So you have to bear with me. Sekarang ni kita baru nak cerita what is logic level. Bila dah ujung-ujung nanti, daripada this experiment, I will tell you what is the difference between discussion and conclusion. Apa tadi nak cakap, saya pun dah lupa. Okay, logic 0 and logic 1. So logic 0 is from 0.7 to 0. So indeterminate state is from 0.7 to about 2.5 volt for TTL. So sekarang ni saya tak nak cerita pasal CMOS because we don't use the CMOS in this class. So kalau if you go to Jalan Pasar Road, so if the thing start from 40 something, 45 something, or 7454 something. So this is what do you call this thing? This is a CMOS punya technology. So this thing will be excluded for the for now. Okay. So sekarang ni saya nak cerita bila awak pergi kat dalam data sheet, you will see dekat tengah-tengah sini ni dia ada tulis 74 something something. Macam kalau kita nak ambil NOT gate 7404 or 74 LS04 or 74H04, 74HC04, 74HCT04. So the letter in the middle will tell you the technology. L, low power. LS, low power Shakti technology. H is high speed. HC is high speed CMOS compatible. Kalau HCT means that high speed CMOS compatible. This is ultra speed recovery. So that will be HCT. So it depends on the application. So in this lab, kita cuma pakai sama ada 74 terus number or 74 LS numbers. Anything with CMOS compatible, 74C or HC, you have to buy on your own. Kita tak supply. So let's say dalam when you will dalam tahun 4, nanti tahun 3, tahun 4, bila nak buat eksperimen, you need this CMOS compatible. Then you have to get your own IC and you have to buy your own IC. Okay. Apa beza dia CMOS dengan TTL? Kalau kita gunakan CMOS, CMOS will be voltage based only. No current needed. Kalau dalam TTL, you need some amount of current to make the gate to switch on. Because this is a transistor. So kalau you still remember dalam transistor, you must have IB. Once you have IB, then only you have this beta IB. Beta is the amplification. Then your switch will be on or not depending on this IB. Dalam CMOS, you don't need this IB. You don't need any current to switch the thing on. What you need is only voltage level. So kalau misal kata macam you do analog experiment, the output will be voltage based only. Then you need a CMOS punya technology. So kalau kita nak kawinkan CMOS technology dengan TTL, there must be something that we have to do in between. So dia panggil ada pull up resistor, pull down resistor. So kalau misalnya daripada CMOS ke TTL, we put a resistor so that the voltage will draw current through the resistor. The current will switch the TTL to switch on atau macam something macam tu. Ataupun we need a pull up resistor daripada VCC sambung dekat resistor and then sambung ke CMOS. Then this thing will provide current to the TTL to switch on. So this is the things that you will include in the discussion, not in the conclusion. Okay. Alright. So when you do the experiment, first kita nak tengok what is the logic level. So apa kita buat? Kita masukkan IC 7404 and then kita increase dia punya voltage for input. Kita slowly, kita increase, kita tengok bila LED tu bertukar daripada 0 1 to 0 or 0 to 1. So dekat this switch between 0 and 1, that will be the transition. When the transition happen, then kita tahu the logic tu bertukar daripada 0 ke 1 or 1 to 0. Dekat situ kita obtain what is the voltage level to turn the TTL 0 or 1. That will be your experiment number 1. Experiment number 2 is to see and tengok macam mana how to how to do the connection untuk dapatkan logic zero, untuk dapatkan truth tables. How to build a truth tables and how to test your truth table. Dia daripada AND gate, macam mana kita nak construct AND gate. So kita ada 4 input AND gate, how to construct. Kalau saya ada masa, esok saya akan gunakan oscilloscope untuk tunjukkan apa yang dipanggil hazard. So hazard ni happen bila ada some glitch. Dia itu jadi bila belajar tu nanti dia panggil multi level. So berapa level? 1 level, 2 level, 3 level, 4 level. So kalau you tengok dalam eksperimen 1B, figure 5, that will be a 3 level. Figure 6 is 2 level. So kalau you tengok sini, the transition between B and C, this will give you a glitch untuk figure 6 bila ada some changes in B and C. So kalau misal kata macam figure 5, nanti kita tengok what is the glitch yang ada. Okay. Itu eksperimen 1B. Eksperimen 1C, this is on how to prove distribution law. So ini dalam apa nama tu Boolean algebra. Kita nak prove the Boolean algebra punya teori. So that will be experiment 1C. So ini yang awak tulis dalam discussion. So experiment 1C is on proving the Boolean algebra, the distribution law. How can we prove the distributive law dalam Boolean algebra. Experiment 1D is to how to construct a truth tables. Multiple output truth tables. So how kita build the truth tables and how can we set the output for the truth tables. So table 2 will be the multiple output. So dalam situ ada intermediate state and then ada output. So kalau kita tengok intermediate state, kalau pakai oscilloscope, then you can see some of the glitches. So the glitch tu yang selalunya kita tengok, yang selalu kita try to avoid. Sebab kat situ terjadinya hazard. Saya tak tahulah nanti dalam kelas akan belajar hazard ke tak. Tapi kalau dulu saya ajarlah hazard. Sebab hazard ni bila dalam sequential network, when you buat sistem tu jadi terlampau besar, then bila hazard occur, dia sometimes they just auto trigger your system. Kita tak nak benda tu jadi, tapi dia jadi sebab ada extra clock yang jadi kat situ. Okay, that will be experiment 1E. 1F ni saya tunjuk aja, tapi sebenarnya selalunya tak sempat. Apa yang ada dalam eksperimen 1F ni yang nak tunjukkan is only the don't care function. Apa yang dimasukkan dalam don't care function? Bila kita buat eksperimen, what is the don't care function? And then kita nak tengok sama ada kita nak ambil don't care function ataupun tak don't care function, and what is this don't care function. So this is the things that you put dalam discussion, not in the conclusion. Conclusion is macam mana the objective of the experiment being achieved. Do you achieve the objective of the experiment? So discussion will discuss every aspect of the experiment. Sama ada dia jadi ke tak jadi, kalau tak jadi kenapa tak jadi, and how to make it work kalau dia tak jadi. Okay, so any question? Nazir ada 7404. Cukup. Microphone off. Okay. So let's say this is 7404 lah sepatutnya. So kalau kita tengok notch sudah dekat atas, kita tengok dekat sini ni dia suruh letak kat bawah sekali macam ini. Make sure kaki dia betul. So dia suruh letak sampai bawah sini. So saya tahu notch dia betul. And then so sekarang dia tak boleh cabut lah. So saya boleh buat dua benda lah. Satu, saya terus auto, saya try find what is this. Dia kata this is 7414. Sama juga dengan 7404, which is not gate, tapi 7414 is a hysteresis. So sama. Kalau CMOS, saya suruh ini loop. Okay, 7404. So let's go pass. So it means that this IC is okay lah. It's in good health. So I can start do the experiment. Okay. So bila saya nak guna ni, saya jangan on dulu. Kita jangan cucuk dulu. Sabar-sabar dulu, buat bertenang. Saya tak nak dia lari, saya letak sini dulu. Apa yang saya perlu buat? Saya kena make sure that all my LED yang saya nak pakai ni must be in the good health. So saya kena check dulu. Tak lama pun. Saya ambil ni, saya check. Okay. Okay, LED okay. So now I can start do the experiment. So what I need is, saya sambung this thing. So ini will be 5 volt, pin 14. Make sure the connected correctly. And this pin 7 is ground. Kau kena tolong aku Nazri, kena strip kan ni. Okay. Saya lupa lah nak bawa stand. Okay. So maybe boleh tengok sini. Pin 7 pergi ground. So what I need is I need this thing. Sambung dekat ground. And then this thing, saya nak check dia punya panjang sebatu. So this is so saya nak check. So this will be my input voltage. Okay, this will be my input voltage. So ini yang saya nak gunakan dekat dalam my experiment. So kalau tengok sini, saya masukkan sini one input to output. So, sebelum saya boleh buat this experiment, saya tengok kat sini, masukkan tak ada, tapi output dia logic 0. So saya tak tahu betul ke tak. So saya test dulu. Bila macam ini, this is 0, 1, 1, 0. Okay. So saya tahu this thing works. Okay. Now I'm taking this. Saya letak dekat my okay. Kalau tengok sini, this is my input voltage and this is my logic output. So saya slowly increase the voltage sampai dia bertukar daripada 1 to 0. So tengok sini ni. So this is intermediate. Kalau tengok, ini belum, ini intermediate dah ni. Antara ada dengan tak ada. Ini dah turn. Okay. So this is, kalau tengok, this is 1 volt. Tadi kita kata 0. Ni intermediate dah ni. This is 1.8. Okay, this is, so this is intermediate. So, ini dah logic 1. So this is logic 0. Ini maximum logic 0, 1 point something volt. So this, in this IC, logic 1 dia, logic 0 dia, is from 0 to about 1 point something volt, 1.08 volt. 1.1, 1.08. That will be the logic 1. So, okay. Apa saya nak buat? Now I'm taking any input. This will be my output. So output from this, saya nak dapatkan dia ada logic. So saya increase bila dia bertukar. So this is logic 0. Okay. Kita nak tukarkan dia pada logic 1. Saya pun dah tak ingat eksperimen saya buat ni dalam tu. Let's see. Okay. So this is my input. Logic 1 dia, IC ni rosak kan Nazri? Sepatutnya dia 2 point something volt. Okay, let kita tengok. This is quite normal. So this IC is too good. Ini mungkin ada H. Selalu tengok tengah dia apa? LS. Okay. So I hope you can take a look at this. So saya nak tengok what is my logic output. Okay. Bila dia tukar, kita tengok what will be my logic output. So this is my kalau tengok sini ni, nanti saya tunjuk. This will be your logic 1. Sekejap Sini. Dia tak pakai. Satu. Okey, tunggu kejap. Saya tak nak charge telefon kejap. Tak ada orang bagi tahu pun video tak ada. Ini semua pergi makan. Okay, that saya akan tunjukkan nanti what will be logic 0 and logic 1. Okay. Tunggu dia nak pesan dulu. Okay, any question? Anything that you nak tanya? So nanti kalau tengok kat sini ni, I hope you can see this thing. Okay. Bila tengok sini ni, bila saya increase from 0, bila dia tukar pada 1, this will be 3.8 volt. So for this 74LS, logic 1 is 3.8 volt. Logic 0 is from 0 to 1.08 volt. So that will be your logic level. Logic 0 from 0 to 1.08. Logic 1 is 3.85 and above. Okay, any question?
Doctor, when you change the logic, is it in the little switch thing at the bottom?
Any question?
Hello, doctor.
On. Semua dengar saya punya suara?
Saya dengar. Can you hear me,
Okay,
doctor?
saya akan upload kejap lagi B2 logic. This is a very simple. Sebab yang lain tu nanti kejap lagi saya pasang. Saya nak tunjukkan satu je lagi. So just give me a few minutes untuk saya pasang eksperimen yang gunakan 2 input AND gate. I'll show you what I'm looking for in that experiment. Sekejap. Let me try cari B2 logic. Saya akan letak B2 logic kejap lagi dalam UCAN folio. B2 logic. Okay. This is a very simple software yang saya banyak guna. Sekejap ya. Okay, saya dah upload B2 logic dekat dalam UCAN folio. You can download this thing and you can start experimenting with the B2 logic. Okay. Internet slow sikit kau punya bilik ni. Lagi banyak dia punya tu, lagi banyak. Lagi slow. Okay. Saya dah upload dalam UCAN folio. You can download and then you can start experimenting. So it's very easy to use B2 logic. B2 logic ni dia license dia dah expired lama dah, tapi kita ada dua logic je, logic 0 and logic 1. Kita tak ada logic 2. Because in binary, you have only 0 and 1. Okay. How to change between logic 0 and logic 1? Switch kat bawah tu is to change your logic 0 and logic 1. Same thing with the pulser. Pulser ni, nanti kalau you tengok video saya dah tunjuk lah what is the pulser is all about. Kali bagi pulse macam mana. Kejap saya tunjuk ya, logic 0 and logic 1. Let me charge my phone. Kalau dia dah naik 5%, dan apa okay. Bila telefon saya dah on, then I can show you what is logic 0 and logic 1. Okay. Tadi awak tanya, what is logic 0 and logic 1? Kalau tengok ke sini ni, saya pun tak tahu. So hopefully my video is not upside down. Or my video is upside down.
Yeah, it was upside down.
Okay. Alright, so this is the switch for you to know what is logic 1 and logic 0. Let me try to connect this thing. Kalau saya sambung sini, this will be, let's see. So this is logic 1, logic 0. Logic 1, logic 0. So this thing 1, kita tengok ke atas sini, ada 1. So this will turn this thing to logic 1. Bawah sini logic 0. Same thing with the pulsar. So this thing, kalau saya tekan, dia akan bagi 1, saya lepas dia ada 0. This thing B0 means that dia akan 1, bila saya tekan dia jadi 0. So this is pulsar. Okay? Am I answering your question?
Doctor, your camera isn't pointed at the pulsar.
Huh?
Your camera wasn't pointed at the pulsar.
Okay.
Okay, now we can see it.
Okay, this is the pulsar. I'm looking at two things now. Sebelah sini saya punya apa?
Understood, doctor. No problem.
Dia tengah nak besarkan saya punya ni. Tapi dia tak nak pergi. View speaker view. Okay. Now I know what I'm talking. But tadi saya tak nampak apa dia. Okay. So this is the pulsar. So kalau tengok sini pulsar 0, 1. Alright. So any question?
One more question, doctor. Is the logic switch connected directly to the IC?
I can easily do that. Let me show you. So this thing connect directly to the IC. See? See? They connect directly to the IC. You see? Connect directly to the IC.
So that's at pin 14, the input, right?
No, pin 14 is VCC.
Okay.
Pin 14 is VCC. Pin 7 is ground. So when you do the experiment, first you have to switch this thing off, and then first you semua connect ground dulu. Kalau tak ada ground, memang your experiment tak akan jadi. First you connect everything to ground. You connect all the ground first. Then only you connect your VCC. Bila semua dah connect ground, baru you connect VCC. Ni jangan switch on lagi. Don't switch this thing on yet. Sampai you dah okay, lepas tu baru you switch on. Okay, give me 5 minutes. Saya nak sambung to input and gate 7408. Bagi aku 2 biji 740 itu input and get. Ini video nak all video ni aku tak tahu. To input and get 740. To input and get 740. Langit gila. Simon tak apa-apa. Aku nak bagi stand sini. Tunjukkan aku buat dulu. Connect. Macam ini aku perlukan anak aku. Computer technician. Let me see. How can I? Ini je. Tarik dia ke depan. Tu boleh ada benda tak untuk tahan kat sini. Okay, nak tahan kamera ni supaya dia tak jatuh. Apa benda? Boleh. Tu satu lagi cukup. Punya kamera dekat sana. Okay. 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 Oh, stripper tu dekat bilik. This is a typical practice. Patutnya saya sambung kat sini, ni sambung sana, tapi saya malas sikit petangnya. Sebab semua wire panjang-panjang, saya malas nak potong pendek-pendek. Okay. So bila saya sambung macam tu, first saya kena try to make sure that I have a correct VCC. Okay. Kalau saya sambung sini, saya tengok I have my VCC. So saya tahu lah connection is okay. Saya off and then baru saya ambil from here to here. Patutnya wire pendek, tapi sorry for this, I don't have apa nama ni, tak ada wire yang cukup. So ini pin 7. So it's a normal practice. Kita ambil daripada luar masuk ke dalam. Allah. Uff. Tak sepatutnya panjang macam ni. Dia pernah buat, saya buat jalan panjang dulu. Just have to bear with me. So I'm connecting this thing to VCC, and there's another one that will connect this thing to VCC. So sini saya nak buat 2 eksperimen sekali. Eksperimen apa? Yang 2 input dan 3 input. Sekali dengan 2 kali. So you have to refer to the dalam bukunya ni dia ada disertakan juga apa yang dipanggil pin assignment. Okay. Bila you buat you punya pre-lab, you must have the pin assignment. Masuk 1, 2, keluar 3. 4, 5, keluar 6. 9, 10, keluar 12 macam tu. So you have to know the pin assignment. Ataupun you boleh sepatutnya di listing kita ada dia punya ni. You boleh download this thing. Assignment. Okay. So in this experiment saya nak buat boleh tengok sini ni. A, B keluar masuk dekat one of the input, and then C masuk dekat input, and then D masuk dekat that input. Okay, so let's do this thing. So first saya ada this input, so this will be A, B, C, D. So instead of dia tak ada tulis kat mana-mana sini ni, so saya just assume that this thing will be A masuk 1, this is A. Semua panjang, apa jadi. Give me a few minutes, saya nak pergi dekat tu. Saya tak boleh hidup lah tanpa wire stripper. Saya pergi my stripper. Okay, sorry, my stripper is at home. So I'm left with a very lousy stripper, but it's okay. I'll try to do my best. So 1, 2, 2 over here. Okay. So 1, 2. So it's a good practice. Bila saya dapat macam ni, I have to test these two connection. So saya kena check dulu. Input satu-satu. Saya kena check dulu. Okay. I have to make sure that my thing works. Satu-satu keluar ni. Okay, saya check dulu. 01. So something is wrong here. Okay, saya tahu my switch ni tak works. Toggle switch saya tak hidup. So saya move to the next one. So saya tahu this toggle switch rosak. Tak boleh pakai. So ini bila toggle rosak, terus tanda kat sini X. Nanti bagi tahu pada Nazri, nanti Cik Nazri akan hantar pergi bengkel untuk betulkan. Okay? Semua faham? Okay. So kalau saya sambung kat sini, ada possibility untuk eksperimen saya gagal. So I don't want to jeopardize my experiment. So simple macam tu. Tak ada masalah, kita buat sikit-sikit, salah sikit, tu sikit, sini sikit, buat kerja lebih sikit, test. Lagi bagus daripada tiba-tiba hujung salah. So masuk satu, this is my output, and then this thing will be my input to the second stage. Second stage. So I have another input. And then saya test pula my output. My output should work lah. Untuk 111, so this will be my output. Okay. So 1, 1, 1. Okay. Then saya sambung. So 111 keluar sini, and then kena tengok pin assignment. Kalau saya tak apa, saya hafal. Kalau awak kena tengok pada pin assignment. Buka balik dekat sini ni, tak ada salah dia. Buka tu tak kena bayar pun. 7408. Tengok dekat sini 7408. 74LS08. Okay. Dia masuk 9, 10, keluar 8. Okay. Masuk 9, 10, keluar 8. So tak ada salah kita buka buku. Yang tak boleh buka buku, masa tengah exam ni, buka buku, salah. Salah lagi dipersalahkan. Okay. Ni 6 is my output. So tengok sini, this is my 6. This will be my output. So this masuk itu sama ada 9 ataupun 10. Salah dia, aku tak ada stand dari kat rumah.
Telefon ke situ, baru dia nampak connection.
Macam ni ke? This will be better. Mana apa popular?
Yang kita nak pakai dalam
This will be very interesting. Alright. I hope you can see this. Nampak? Boleh ikut ni. So, this thing, my input. It's another input. And then I have one output. So this thing will be my output. Bila saya in, so 1, 1, 1, 1. Apa yang sebenarnya kita nak tengok kat sini ni? Yang kita nak tengok sebenarnya dia punya intermediate state. So I have 2 intermediate state kat sini. One intermediate state, which is this. Ini satu intermediate state. And I will look for the other intermediate state. Saya betul-betul ingat hari ni face to face punya lab. Dengan yakin yang saya ingat hari ni face to face lab. So now 1, 1. So this thing is 1. 1, another 1. 1. So kalau kita yang ini kita nak tengok. So ini okay. So this one. This is where the hazard will occur. So macam mana kita nak tahu bila benda ni bertukar dengan cepat? Kita kena guna oscilloscope. So ini siap satu part. I will do another part yang dekat bawah sini. So kalau saya tengok bawah tu dah jadi, meaning that yang atas ni pun the other one will be the same. So I'm using the same input. Sorry. Berapa benda jatuh. Okay, good. Jatuh juga. Okay. So now I'm taking this 6
Macam tu.
and then 3. So switch on. Okay. Everything is in is 1, 1. Okay. This ini sistem 1, output 1, output 2. Jadi sistem 1. So kalau kita tengok sini, bila saya bagi testing, the first experiment sebab ada multi stage, dia akan ada 1. Only this, kita tengok. What we want to see is when this thing is 1, this thing is, kita nak tengok what happened dekat sini ni. So only oscilloscope will tell us the story of this thing. So now I will switch on my oscilloscope and then I will show you some. Kalau dalam your experiment, awak akan gunakan oscilloscope for this experiment. But for this purpose, I will show you by switching on the oscilloscope and then try to show you what actually happens. Saya nak tengok only the intermediate state. This is what I'm interested in. So saya akan tunjukkan one by one dia punya intermediate state. So the first intermediate state. And this is your second intermediate state. I hope you can see this thing at the back. Ke depan kan. Ini yang saya nak tunjukkan, intermediate state. Okay. Kalau kita tengok, dia punya delay dia tak banyak. Ini multi purpose. Silap. Mana dia punya time? Horizontal.
Ini scale. Ini untuk vertical, ini horizontal. Ini position untuk horizontal.
Horizontal. Vertical scale.
Dah kecil sangat dah. Ini dah masuk ke step tu. Tak boleh terlalu laju. Satu.
Apa saya nak tunjuk bila dia dekat sini ni. Tengok. Yang ini saya nak tunjuk. When this thing happen. Okay. Bila saya switch this thing, dia bila dia berubah dua ni. This is when things happen. One of this start working. About this more one. Saya nak tunjukkan kat sini je. Terus saya nak magnify benda ni. Saya tak biasa dengan skop ni. Skill. Aku dah trigger betul lah tadi. Trigger ada correct point. Tak boleh. Apa-apa yang saya nak tunjuk kat sini ni, kalau saya dapat expand benda ni, then kita akan see the glitch between these two. Yang atas dengan bawah. Kuning dengan biru. So dalam eksperimen, dalam your lab eksperimen, awak takkan buat benda ni. Selalu kalau macam-macam ni saya buat demo, saya akan tunjukkan lah. So this is the things that you put in your conclusion, in your discussion. So dekat sini kita boleh tunjukkan hazard bila dia berlaku. Sebab kita tukar dia punya gate. Tapi bila benda ni jadi, dia bila benda ni berlaku tapi tak ada apa-apa terjadi. Kita nampak macam sama. Tapi sebenarnya ada benda yang berbeza antara dua ni. Hopefully I can show this. Oh, tak keluar tak? It's not in the frame. Dia tak keluar frame. It's not in the frame. Tak ada dalam trigger frame. So it's okay. So this is your experiment mana tadi kan? eksperimen ni tak adalah sedahsyat macam ni sebenarnya. So saya dah buat eksperimen 1B, lepas tu eksperimen 1C, 1D dengan 1E. This is how to construct a truth table. So ini sama je dia punya eksperimen. Untuk tu you boleh gunakan B2 logic untuk buat this thing. You can do any apa nama ni, you can use any simulator for this. Saya tak kisah sangat nak pakai apa-apa simulator. You can use any simulator. But if you want to use B2 logic, awak tak akan nampak lah macam apa saya tunjuk kat oscilloscope tadi. You will be able to see that thing. Kalau pakai simulator yang canggih-canggih macam ORCAD ke EWP dengan ORCAD sama, ataupun Eagle. Tapi kalau nak lagi bagus, pakailah macam multisim okey, ataupun nak lagi canggih pakailah macam Intusoft, ataupun nak pakai microcap. So you can use this simulator to simulate the logic yang macam saya tunjuk, and then you can see all the glitches yang saya tunjuk tadi tu. Walaupun saya tak dapat tunjukkan, saya tak dapat expand that time frame, then you can, but you can see in your simulator. Okay, anything yang you nak tanya? So saya will end my lab demo sampai takat ni. Okay, I want to show you the hazard. Saya nak tunjukkan the glitch bila ada hazard. Because itu very small time frame. It's only a few microsecond. Tapi saya tak dapat expand that thing. Sorry about that. Sebenarnya benda ni tak ada pun dalam your lab experiment. I just want to show you that the glitch is there, and this thing will disturb your experiment later bila you buat sequential network.
Doctor, do you mind muting your other device?
But that is the point. Circuit tu you boleh buat sendiri. Ada macam-macam cara you nak connect. Okay. So kalau tak ada apa-apa, okay, bila you dah habis eksperimen, awak kena cabut semua lita-lita ni. Wayar-wayar semua kena cabut. Lepas tu wayar letak dalam bin dia. Kalau wayar yang pendek-pendek, awak boleh tolong kawan-kawan awak on the next day by using ada satu, sepatutnya nanti saya tengok kalau saya ada video dia, I will take the video and show it to you lah. On to use this, ada satu alat panggil Gallic Axial. We will use this simple machine. Let me try to show you. Untuk gunakan Gale axial ni to straighten the wire. So wire nanti awak letak balik ke dalam the wire bin. Any question? Dalam eksperimen ni, eksperimen F tu you can do it pakai simulator je. Itu untuk awak tahu macam mana nak construct don't care function dalam truth tables and dalam Carnot map. Actually this experiment up until Carnot map. So macam mana nak guna Carnot map? Selalunya nanti saya tengok dia dalam YouTube ya. Kita patutnya ada YouTube-nya channel ni. Let me see if I still have the YouTube channel for this. Okay, dia tulis apa situ tu saya tak ingat. What error do you have? Cannot execute. Oh, ini you kena expand dulu. Saya bagi you zip file. You kena unzip dulu. You have to unzip. Letak dalam satu folder. Then just run that thing. Dia tak ada installation. Dia tak ada installation ni.
Sorry to disturb. We have
It has
tried
no installation file. You unzip and put into one directory. You can even run from your thumb drive kalau you tak nak. B2 logic is the simplest things. Apa pucuk tu Nazri? Tu, pucuk. Pucuk. Ini ada orang repair tandas ke atas ni. Buat tandas. Pergi naik atas tandas, cepat. Dia tengah repair tandas atas. So dia ada accident. Ada mop, dah panggil makcik. Kemungkinan itu tandas. Ini daripada di rumahnya.
Doktor, selamat petang. Doktor, selamat petang.
Hello, doctor. Can you hear me?
Okay. Saya tengok ada some of you. Yes, Tan. What do you want to ask?
Ya, doktor. We download the file.
Nak tanya apa?
Kita
trying
download
to
the file.
Set B2 logic. Sebab saya tak ada masalah untuk install this thing last time. Oh, ini ni you kena run and you kena set this thing masuk kat dalam administrator, and then you kena tukar pada compatible to 32-bit. Sebab this software is 32-bit. You are running on 64-bit. Your processor is on 64-bit. Kalau tak boleh run bit-to-logic, tak ada masalah. You can use any other software to do your simulation. Any problem? Any other question?
Sorry, doctor, just want to confirm again. So are you going
Nanti saya
to
try tunjukkan bit-to-logic, how bit-to-logic works. Kalau tak ada bit-to-logic, you can use any other things. Ada banyaklah new bit-to-logic yang baru pun ada. Dia panggil bit-to-spice. Okey, saya kena sign off sebab bilik ni bocor. So saya kena itu. Okey, so saya akan upload semua benda ni, termasuk video ni kejap lagi dalam YouTube and Ucamfolio, and then you can start do your experiment by using circuit simulator. Okay, so I have to end the class sebab bilik yang saya gunakan ni, bilik lab digital ni dah start bocor. Okay, any question? You boleh tanya saya punya wakil kelas lah. Sekejap, saya tak ingat wakil kelas saya. Let me see. I cannot remember his name. Wakil kelas saya untuk kelas ni, you can tanya Lehli Yu dengan Ramdan. Itu wakil kelas saya. Okay. As I said, you tak boleh install sebab software ni 32-bit and you are running on 64-bit punya komputer. That's why dia kata the app can't run on your PC because you are using 64-bit. Okay, Lely, you, that is the problem because you are using 64-bit.
Thank you, sir.
Aduh, saya